This tutorial focuses on what we can do with our data once StatMiner has finished the qPCR analysis and we have the relative quantification results filtered by a set of detectors of interest. Please check the user manual or differential expression video tutorial for further details on how to filter expression reports. This example represents high doses of a certain treatment compared to the control group of the experiment. We have a list of regulated detectors. So, what is next? Is it possible to put these detectors into a biological context? For instance, can we get further biological information about the genes of interest, or map them into the biological pathways? Going step by step. First question can be answered using the StatMiner link template tool. This tool can be accessed from the data table that summarizes all the relative quantification information that StatMiner has calculated. It gives us a chance to query websites by asking for any kind of information provided by the site in relation to our data. For instance, asking Sanger about our regulated detectors. In this example, we will ask about our detectors and we can search using any information available from our data tables, not only the expression table or the detectors. Let's open the tool. First of all, we have to define the column with the values that we want to query on the website. And now add a new template with the URL of the site to be consulted. We can give any name to this template. This is the URL that we need to ask Sanger. It is recommended to check the user manual for the section that describes how this URL works. For the purpose of this tutorial, we are now only connecting with the Sanger website for our detectors of interest. However, we can set up additional queries to multiple sites if needs be. We are done. Now let's apply our template. As we can see, the detectors are now highlighted, indicating that if we click on them, our search will be visualized in our predefined web browser. Let's try with this detector. And that is all. We now have access to the Sanger knowledge base with full information about our detectors of interest. Let's continue this tutorial by addressing another question that we previously asked. Can we put our detectors in the context of their biological pathways? The answer is yes, as StatMiner is integrated with the Ingenuity Pathway Analysis tool. This third-party module by Ingenuity Systems gives us a chance to analyze and have a better understanding of complex biological systems. Upon this integration, StatMiner sends our list of detectors of interest, including expression information, RQ and FDR p-values, and IPA tools pops up as an independent platform from the web browser. Let's see how to send our detectors and associated expression values to IPA. First setting to configure is the IPA server. StatMiner is already configured with the default one, but we can replace it by any other custom IPA server. In this case, we will use the default option. An IPA observation is just any of the comparison that we have performed on the differential expression analysis. For example, we have analyzed a high-dose treatment versus the control group. If we had performed multiple expression comparisons, we would have multiple observations. In this case, IPA will receive the list of regulated detectors. That is why we set this option, and the RQ and the FDR p-values of high doses versus controlled. Only one setting is now left. We have to choose the gene ID type and we are ready to run IPA. If we make a mistake and if we define a wrong ID, IPA will show us a similar message saying that it is unable to map any of the detectors that we have sent. Stem loop is the correct one for our example and we are ready to go. From now on, everything is done on the IPA site and we will be asked for our IPA credentials. Please note that these are not included with the StatMiner license. IPA will proceed to check whether our computer is properly configured to run it. Java is a requirement and will ask us to run its Java WebStart application. Once the process is finished, we are able to open it and have full access to IPA functionalities. For instance, mapping our genes into pathways to perform network analysis, create graphical diagrams, and use the search tool to obtain further details about our detectors, etc. Regarding our experiment, we can now check whether the information has been properly loaded. The identifier, the list of detectors of interest, associated RQs and FDR, as well as p-values of each one. New observations coming from StatMiner would be populated on the right side of the panel. Finally, and before starting our analysis, it is also important to validate whether IPA was able to recognize all the detectors that we sent by checking the dataset summary. We are done and would like to advise you that this is a one-way integration only, and results from the IPA tool cannot be imported back into StatMiner.